I know when we do some of these webinars, the crispness doesn't always come across depending on graphics cards, depending on bandwidth, depending on CPUs and things like that. But hopefully you'll be able to see the image pretty crisp and pretty clear. And I should also say I have a couple little videos on here, and those don't translate very well sometimes in a webinar. But I think, Jeff, we're going to be recording this for playback, and so they can come back and look at it again. Is that correct? I don't see Jeff. Okay, so I'll keep going. So
yeah, sorry about that, John. Yep, it is. It's being recorded now, so there will be a link that you'll have, and it'll also be on Labstar.
Perfect. That's what happens when you mute your phone, then you go to talk again, and it's like, oh, I forgot I muted. So, all right, so here we go. Let's jump in. Let's talk a little bit about 3D printing. And I should say in our lab, we've been doing this for a couple of years now. We knew that 3D printing was going to take off, and it was going to have an effect on the dental lab industry and the dental lab business. But we really didn't know how. We didn't know what it was going to do. We didn't know how it was going to do it. We just didn't, quite understand everything about it. We understood it somewhat conceptually, but we didn't understand. So we just jumped in. So we jumped in with a low-cost 3D printer, and we learned a lot from that experience. And we learned exactly the power of 3D printing and why it's important to get a quality 3D printing, one that you can actually use in the business. And we found out that not all 3D printers are alike. So with that, let me just keep moving in. This one, it's called additive manufacturing. We all call it 3D printing, but the actual term is additive manufacturing. And this technology has been around since 1980, 1986, when the first patents were first issued. And so they're like, 38 years in development. It is a pretty mature technology, but it continues to develop. Patents are good for 20 years. So after 20 years, what happened, and it was very costly. In fact, Union Tech, when we first did our first printer, was close to $1 million for a 3D printer. But now, over the past 20 years, and as patents have come off, the prices you see are coming down. That's why you see so many of these hobbyist 3D printers take hold in the last few years, is because they can manufacture these things without having to pay the patent cost. One of the newer, you see Carvin is out with a new technology, and that's called Clip. I'll talk about that in just a second. And that's a new, their patents are about 2013, 2015. They build upon the same patent, the same technology that's out there. They kind of build upon it, add a little tweak to it. So those patents are going to be there for a while. It's basically 3D printing is nothing more, as it says here, it defines the manufacturing process when material is being joined or solidified a thin layer at a time to create a three-dimensional object. And basically, you design this on your computer to design the model, whatever that model is, whether it's a surgical guide, whether it's a physical model, whether it's a crown and bridge, whatever it might be. You create that on your CAD/CAM system, and then you send it to a nesting software where it gets sliced up in different layers. And those layers, depending on the thickness, can be 300 layers, 400 layers, 600 layers, and then then it gets sent. That file gets sent to a 3D printer where it's actually printed a slice at a time, and it's printed a slice at a time different ways. The benefits of 3D printing is you can create one-off custom products, prototyping, and you can do that cost-effective, accurately, and fast. And in the dental industry, as you well know, particularly in the lab business, one-off custom product is what we do day in and day out. Some of the concerns that labs have, that we have, from a staff perspective, from our own perspective, what's the learning curve, what's the accuracy, and what's the ROI? And those are some of the concerns that we had to overcome. We had to understand better, and we did. But let me give you an idea why there's so much confusion in 3D printing, particularly in our industry, but over the industry as a whole. There are all sorts of different types of 3D technologies. Extrusion process, which is diffuse deposition modeling, or diffuse filament fabrication. This is the Stratasys. They came out with this patent and this technology years ago, and that's one form. But then you also have the poly, or the photopolymerization, and the resin process, and that's what you hear about, SLA and DLP. But then you also have powder bed fusion process. Powder bed fusion process is where you have a bed of powder, and a laser or light goes in and fuses the powder, and then when you get through, you dust up all the powder from your model. Material jetting process is another one. It's almost like an inkjet type process. They have binder jetting process, sheet lamination process, 3D bioprinting. So there's a lot of different types of technologies within 3D printing. We focus on the extrusion, the photopolymerization, and now this continual liquid interface production, which carbon. A lot of people have seen the TED program. They show the carbon clip. It's a little bit different. So I want to touch on the three that are in red primarily. But if you're wondering why there's a lot of confusion, because there's a lot to 3D printing. There's lots of different options, lots of different technology. So let's talk about fused deposition modeling to see this within the Stratasys systems. And this is where they use a continuous filament, a thermoplastic material, and it gets fed from a log coil and it moves through a heated printer extrusion head. So you have a printer extrusion head, and it does it a layer at a time. And these are like 140 microns, 100 microns. And so what you have in a fusion, you have it where you have a print head that goes back and forth, but you also have a plate that goes back and forth. And then one layer at a time, that printer goes through here, goes one layer at a time, one line at a time, and creates that model. And it's very, very thin. There's types of stereolithographic. There's 3 or 4 types here, and one that you're familiar with is probably SLA. And this is where it shines an image on the screen, and then it fuses that image with light, with lasers, or with a DLP process, digital light processing, or LCD process. But this is where you have a tank of resin here, of liquid resin, and the light hits the resin, and it hardens. As soon as that light, the laser or the light hits the resin, it solidifies it and hardens it. And then it does the next layer and the next layer. So there's 3 different types of stereolithographics, but the end result is the end product. How they make it. Well, the difference is speed and accuracy and quality, and that's what the big difference is between these 3. They end up with the same product, but the product's different based on how long it took it to make the product and what the quality accuracy of that product. In the dental industry, we need quality, we need accuracy, particularly for doing things like implants or analogs and those types of things. And here's another rendition. Now the laser, think of the laser like we had our Forms Lab printer, and when we first had the Forms Lab printer, it would just take forever and a day, because it would take a layer and it would have to color in, if you will, with that laser. And of course it's pretty fast, but it has to color in every piece of that layer. Every layer, it has to hit that piece with the laser. With the DLP process, it just hits the whole image all at once. It just booms, it hardens in a couple of seconds, and then it goes to the next layer. With a laser, it has to color in, if you will, the entire layer, a laser at a time, and then it goes to the next layer. And then with the MSLA, it just kind of reverses the process of DLP. It instead of just shining just on this, it masks it and just shines on that one piece. But typically, MSLAs lack the same resolution that you get from DLP. Of these 3 components, that your DLPs gives you the fastest and the most clear accuracy that you can get on a stereolithographic 3D printer. Now, here's a video that kind of gives you an idea. I don't know how that translates over in regards to on the webinar. We were looking at this yesterday, and I don't know if it's jumping or not, or how it's going, but basically it kind of gives you a good idea of how the process goes here. So you can see the laser hits the model, and then the model comes up from there. So hopefully you saw that, and it worked out pretty good. But that's how a laser, as opposed to a DLP. Digital light process is a little bit different in that you have a projector down here, you have your resin here, and this part here is called the build platform. The build platform comes up and down, as you can see in this video over here. Again, I don't know how well the video translates, but it's a time-lapse video, so it goes pretty quick, and you can see it's going up and down, up and down, up and down. And so that light hits the layers, and every time it hits a different layer, it hits it, it hardens, and the build platform comes back down. It hits the layer again, the build platform comes back down. And it does it until it finally ends up with the product, like on the right, where you see some surgical guides on a build platform coming out of the wet resin tank. And so you can see where a laser does the same process as far as coming up and down. It does a layer. It has to color in the laser, if you will. The DLP just shines the light, it moves faster. We found, and our laser printer our 3D printer that we have right now compared to our Forms Lab, the DLP is like 4 times faster, and so we don't have to wait around for models or whatever we're printing to, we don't have to wait 4 hours to do it. We can print them pretty quickly. And then here's another idea. I just want to show you. I hope this comes up. This is a model on the digital light processor, or 3D printer. And you can see to the right, it shines that light, and that's what it does. I put that sheet of paper on the 3D printer to capture the image, but you can see it'll shine that light. It'll harden. The build platform goes up and down, and then it shines and does the next layer. And it does that through a number of layers until it gets through with the model. And just so that you understand continuous liquid interface production, that's a clip, the one that Ted does. It's the same process. Like I said, they build upon the same process, but it builds the same process, but they have a layer of, they call it the dead zone between the glass and the resin. And the concept is so that it doesn't have to come back down. The build platform doesn't have to come back down for every layer, but the build platform can continue moving up, and so it's a little bit rapid. The problem with that, it's still patent technology, so it's very costly. It's a closed system. They pretty much control the entire system, if you will. And it's expensive. Right now they're selling, but they're subscription basis. You kind of rent them or lease them. You don't really ever own them. It's more of a subscription, like you would do your Adobe Photoshop or Adobe Creative Suite. And at LMT, we're looking at these things, and they had a pixel resolution of 75 microns, which is okay, but it's not great compared to what you get in a DLP. And it's still really under development. They're selling them, they're pushing them, but initially when they first came out, we called them up to see if we could get what we had to do to get one of their 3D printers, and they just were they were just over the top expensive, and we just didn't have the budget for it. But this is technology that's coming out. Hopefully I'm not going too quick for you, but I know we have a lot to cover in a short amount of time, so let me continue. I want to make sure you understand the thickness of layers in microns. I'm sure most of you do if you're lab technicians, but a layer, we print everything about 50 microns. It's about the size of your human hair, but that kind of gives you, 40, 25. You can print things at 25, but they're just going to think about it. If you printed things at 50 microns and you had 300 layers, well, if you print things at 25 microns, now you're going to have 600 layers. So it just doubles the amount of layers that you have and the time that it takes to design them. We find that with most of our models, we can print at 50 microns, and they're fine. There might be some reason to print at 25, but for the most part, 50 is fine. And this slide, hopefully it'll come out great. You have it shows the thickness on layers, and you can see on the cat's head here, this one on the far right is 400 microns layer. Then we go to 300. Then we go to 200. Then you can start seeing at 100, those layers start to disappear. You don't really start seeing them. So if you go to 50 and a 25, they're all but gone. And here's what happens when you send it to the software. Once you create your digital model on your 3Shape software, or your Sharona or ExoCAD or what have you, you take it to nesting software, and in the nesting software, it slices up those images a layer at a time, and then it creates what we'll call PNG files, PNG files, graphical files. And you can see each one of these files is a little bit different. If you get down here to the far right, that's a layer. So it's just like a slideshow, if you will. The first slide hits the screen, and it gets hit with the light, and it hardens, and it goes to the next slide that gets hit with the screen, and it hardens, and the next slide, and the next slide, and it goes to that till all the layers are completed, and it starts at the bottom at the top until they're all completed, and then you have your last layer, and you print your model. Now, so when you go talk to somebody with 3D printers, they're always telling you, oh, ours has 50 microns layers, ours has 25, ours will do 10, ours will do whatever. But that's just part of the story. The other part is the layer is one piece, but how accurate or how fine is the actual pixel resolution? And this is an important part of 3D printing. Lasers don't really have pixel resolutions because they have a laser and they're kind of a round tip. Here's an example down here of a SLA nozzle size, 140 microns. I think this is what Ford's Labs use, but you can kind of see it has that round size. So when it colors in that shade, it's using this nozzle and has kind of a round pattern to it. Where DLPs are, they use more of a bitmap, not a bitmap, but they use a grid if you will, a pixel. And the smaller the pixel, the higher the resolution. And MSLA uses the same type of technology, but for whatever reason, that technology just doesn't get as clear as the DLP type technology. And you can see here, the difference between a curve with a resolution where the pixelation, where the pixels are much smaller, as opposed to here where they're much larger. So the finer in microns the resolution, the better you're going to have a printed model. So you could have a model that has 25 microns as far as the layers, but if it has 140 micron resolution, it's just not going to be that clear. So those two work hand in hand, and so you want to make sure that you look at printers that have a high, or I should say a low. 58 microns is pretty small. And to give you a better idea of that, think of a 4K resolution on a TV. If you look at the pictures of a 4K resolution at 38 by 40 by 21 by 60, as opposed to an SD resolution, which is 720, you can tell just visually. We can see that in our screen. Pixel resolution matters because it determines the precision, the accuracy, and the perfection of your model, whatever that item might be. So why is resolution important? Precision, accuracy, and perfection. Hopefully you can see, this is a model we printed here. You can see it has the analogs in there. When you're placing analogs and you're doing implants and some fine detail work, you want to make sure you have incredible accurate models. And this is where the resolution comes important, so that you can actually get a fine and an accurate resolution. So now I want to jump over to understanding the workflow to profitability. If you have any questions, feel free to chime in with the chat to Jeff, and we'll get those answered on that piece on the 3D printer. But I want to talk about the workflow. We're a digital lab here, so we have Sirona, we have ExoCAD, we have Roland's, we have MCX5s, and so we have a number of digital printers. And so we wanted to understand exactly how to incorporate the 3D printer into our process. And so obviously the first part is design, what we're doing now, but then we export that into an STL file, and it goes into a nesting software. And the nesting software is where you virtually put it on a build platform, depending on your printer, and it slices it up. Once it slices it up, then you put it to your printer takes those slices, prints them one slice at a time, and then you have post-print production, where you have to clean it with the alcohol, get all the resin off, and you cure it. And at the end of the day, you get a product that generates revenue for you. Now, these steps, to kind of give you an idea, it can take design 5 to 30 minutes. The nesting process can take 5 to 15 minutes working with the software. The 3D print can take 60 to 300 minutes. It can take, depending on how you're sitting on your platform, what type of 3D printer you have, what the resolution set, those types of things. Those are all printer dependent. And for our lab, my son's lab here, we wanted to make sure that we had we started off with it very, very slow, and it was just killing us, and we found out the importance of speed. And then the post-print process, 15 to 30 minutes for curing it. But the generation revenue here is we have new products. We control so much of it so we can have faster turnaround. We find there's new business opportunities for our lab. It's new and enhanced digital workflows that we're working into. And the best part about this is position us for the future. As the lab business continues to change digitally, we want to make sure that we're positioned in the future for it. And now, as far as possibility, what's the cost of these things? Well, the design to export, that's whatever software you're using, whether it's an ExoCAD solution or a full-blown Sirona 3-shape, solution. There's usually cost there. But as far as the nesting software and the 3D printing, you can get anything from $5,000 to $100,000, from the hobbyist end, what I call the hobbyist end, from a Forms Lab solution to a Stratasys, which is extremes. And you see companies like Stratasys, EnvisionTech, Evident. All those are great. They produce a great product. It's not about producing a great product. It's what price point you produce that product at. And then on the moving over to the post-curing end, you just need to make sure you clean it with the right type of alcohol. You do proper cleaning, because if you don't clean it correctly, you put it into a resin tank. If you have any leftover resin on that model, it's going to cure as well. The next piece of the workflow, like I said earlier, it's the right software with the right 3D printer, solution, and resin, and then the right materials. All that plays a part of being profitable in a 3D print solution. Now, resin is an important part of the equation because it's like having a car and not having any gasoline. You have to have resin. And so we use, in our lab, we use NextDent's resin. NextDent is a company that designed nothing but resin. They manufacture nothing but resin. I think they were recently bought last year by 3D Systems. But they have excellent resin. You can see the different types of resins they have, whether it's tray, model, ortho model, surgical guide, ortho clear and rigid, bonding trays, crown and bridge MFH, which is, we've used that, and that's really cool, and we've used it. We did some perfect smiles / Hollywood smiles where you just snap in smiles, and that worked incredibly well from there. Base for removables, and then cast and gingiva mask materials. All these materials work out great. They sell them for anywhere from roughly $180 to $200. Some will be a little bit higher in price than that. Maybe the ortho is a little bit more, but that kind of gives you an idea of the resin cost. Keystone's another resin manufacturer. Again, $180 to $200. They have the same type of resin. Everybody's coming out with resin. Resin's the consumable part of a 3D printer. And this resin, in the last year, what we found, 2 years for sure, has been changing exponentially. It's amazing how much resin has changed. I think NextDent has like 5 different colors of denture-based material now, and so it just continues to grow and develop. And now, resin is key because 3D printing can be an open or closed solutions. Forms Lab, when we had Forms Lab, we had to use Forms Lab resin. We didn't have any choice. If NextDent had a great resin, we couldn't use it. We had to use Forms Lab. It's true with a number of the 3D printing solutions. You have to use whatever resin they tell you to. If it's an open solution, like Eviden, our printer that we're using now, it's an open solution, so we can use NextDent, we can use Keystone, we can use whatever resin's out there. And you'll see that a lot in the hobbyist world. A lot of the hobbyists, they don't tell you what resins to use. You change that, but the reason we use the NextDent resin is because it's the reason we like about the Eviden printer is that it's open and we can use any type of resin we want. Of course, it has to be certified and has to be configured for it, but for the most part, it works great. I'm getting a can't install update. Hopefully that'll go away. There it goes. Also, understanding what for the profitability, the best part of this is, number one, is control. We have control of our model printed in-house. We get a lot of digital cases, and every now and then those digital cases, these models printed. We don't need to send them out. We get a fast turnaround. We have control. What we print, how we print those. We get to decide whether we want to do a die cut, gingiva, if we want to add teeth. However we want to do it, you get to control that in your lab. If it's an implant model, if it's a surgical guide, we get to print those. We get to see the accuracy. We can measure the accuracy and make sure everything's good. But we don't get it back from somebody else and find out it's not quite what we wanted, and they have to turn around and redo it again. So it's about control. And then if you're doing removables, understand what's on removables. Removables, you have try-ins, you have base plates, you have frames, you have teeth. Again, increase the turnaround. You control the manufacturing process. We do digital to Atlantis. Now you can do digital. If we want to manufacture the frame and send to Atlantis, we do, or we can just burn it out in our own oven here. So I hope those images come across for you. You kind of see some of those in the removal department. And there's the teeth that we printed in the middle there. We printed those in the model that we printed in-house for customer, patient. And ortho, some things that we're doing, we don't do a lot in ortho, but we'll get into it. With the ortho, you can print the appliance model, the indirect bonding tray, bite splints. Again, it's increased turnaround. We get accurate prints, and we control this whole process. So 3D printing allows us to do all that in-house where we weren't able to do that before. Let me take a timeline and continue on, give you an idea of cost of ownership. So this is what we did in our office when we analyzed some of these scenarios. You had scenario 1, scenario 2, and scenario 3. What is the cost of these 3D printers? Well, I discounted the forms that we bought that. We understand it's a hobby. It doesn't meet what I would call a real lab's need. It works okay, but it's just not precise. It's not accurate, and was just more frustrating than it was anything. So while hobbyist 3D printers are there, they're not, industrial type of 3D printers that we're looking at. And, we looked at the Envision Tech. John's our rep with Envision Tech. He came over and visited with us, and we really liked it, but really just a little bit more than we wanted to spend. And David with Stratasys came into our office here, and, he did a great job. We really liked their printer, but we didn't want to spend $100,000 for a 3D printer. And so we looked at the cost of the printers. We averaged it out for a 3-year life, maybe because it's a 5-year life, but I did it on a 3-year life. And you can see kind of what it costs per year on a 3-year, and the cost per monthly basis. And then, per work, we have 251 work days in a year. You can see how that breaks down. And then we figured if we get 2 arches per hour, we can get more than that, but I'm just saying two arches per hour to kind of keep it simple. What's it going to cost me per arch? And then we looked at, when we looked at, again, this is a pixel resolution of 73 microns, which is really good, but here I have one at 58 microns, which is incredibly better. And so we took all those things in considerations, and this is kind of how we broke it down for a total cost of ownership on it. And then I should also mention, look towards the future. We look at, here's the traditional workflow that we were used to in the past, where it went from the dentist's office to the lab, back to the dentist's office by courier. Now we're getting a lot in this current workflow. We're getting a lot, maybe it used to be when we first started like 80% digital, the rest are traditional. Now we're getting more like 50% or more digital, 50% courier. We turn around 3 to 5 days and we send it back to the office, via courier. But the projected workflow we see happening, where the current workflow is traditional with digital, is becoming more digital with traditional. Now we're starting to see more and more digital stuff coming to our office, less by courier, more by digital. We do the digital design, fabrication, delivery, and some of those will even send a file and they'll mill it in the dental office, or they'll print it on their own 3D printer in it, or we'll manufacture it and send it out by courier. But this is where we see the future going as far as this projected workflow. There's always going to be room for courier. Don't misunderstand what I'm saying, but we're seeing more and more digital happen. And finally, summary takeaway, 3D print technology applies to all aspects of dental restoration. It's an opportunity to reinvent workflows and processes to streamline current products and add new products. And again, accuracy, speed, and resin is key. And what we're wanting to do, and this is a look of our lab in our office, we want to position for growth. We're all about growth here, and we want to position for growth. We don't want to be left behind. We want to make sure that we are positioned for the future. Lastly, I'm going to leave with this, but we'll take some questions here. As part of this, we want to provide a promo for Labstar clients. And so this is kind of give you an idea of the promo that we're doing for Labstar. Here's the EVADET printer that we use. Again, you saw it here. We have 2 of them in our lab. But we put it here. It's a DLP printer, $15.99. It's a $20,000 value. You can do the numbers there. But we're doing a promotion for the Labstar customers for $15.99 for the kind of a total solution. It's a DLP. It's 58 microns. It's an open source resin, variety of materials, and they've been in business for nearly 20 years. So there's my time. I went over a little bit over, Jeff, but that's pretty much it. I thank everybody for the presentation. I'll take any questions.
Thanks, John. So we have a couple questions queued up here. I want to remind everybody, if you do have questions, up in those circles at the top middle of your screen that you're looking at, it's the desktop sharing app that we use called Join Me. You can click on those, and you'll click on the one with the little chat bubble, and you'll be able to ask questions. But we have a couple. We'll go right directly to it. John, I was laughing. I don't know if anybody remembers, but what was it, about 10 years ago in Costco, you could buy DLP television sets right before the LED. This is a different kind of DLP, clearly. How are doctors reacting to the digital workflow? I mean, are they aware of the printing that, say, Express is doing? In other words,
of course,
at the other end of the process, are they seeing better results? What are they reacting? What do they think?
It's a great question. First of all, because we're getting a lot of oral scans, and we're getting from doctors, they don't have a model. Those oral scans don't come with a model. In some cases, they want a model so we can print that. They can see the accuracy. Or if we're doing like implant cases and things like that, it's everything captured digitally. then we can, print out those models as I showed earlier, that one model with the analogs in it. And so they're aware of it, even to the point that I think in the future, doctors, like particularly orthodontists have 3D printers in their offices to print out to print out their product there in their office. And what we're seeing there, they don't really want to do the design work. They don't really want to train their staff to do the design work. So they're looking to labs to do the design work and send them the file, and then the file will go right to the 3D printer and it's printed. And so they do the post-curing, post-print process in the office. And so, it's the same way with milling. We have doctors that have mills and Sirona or 3Shape or exocad in their office, and sometimes they just don't have the expertise to do some of these complex cases. And so they'll look to the lab, for our lab, to do the design work here and send it to them, and then they'll mill it on their mills. So that digital workflow from 3D print is just an extension of what's already going on now, and we see it continue on into the doctor's office, the dentist's office, and whether it's oral surgeon or dentist.
So when the doctors are starting the digital workflow, do you have clusters of doctors using different sort of starting tech, whatever, from 3Shape to Sirona to, how do you, are you marketing to those doctors, or are they finding you, or is it sort of growing organically? How do you start that digital workflow with the docs?
Well, it's a little bit of all of it. Now, we would go knock on doors in the doctors, and we would promote our digital oral scanner type deal, and then that would lead into the conversation. And some of these doctors might not have any technology, so we give them our opinion, or they might have some technology and they understand it. Or they might have 3Shape, they might have iTero, they might have Sirona, and we work with all those, and we let them know that we work with all of them because they send us, that's all sent digitally to us. And so we make them aware of what we're doing as far as the digital workflow, and then we supplement that, with all the technology, whether we're scanning traditional trays, whether we are in printing models, or we're just working off the traditional, off the digital tray, if you will. But we communicate that to them, and the result is it's much more accurate than the traditional methods. The current digital workflow is just much more accurate than what it used to be.
Are you finding, so we have one comment from one of our viewers saying that they find at Lightning Dental that the formats are a problem when getting files from a dentist. How do you handle that issue?
So we get them from different, so whether it's 3Shape or Sirona via Connect or iTero, whether it comes from Costa Rica or wherever they go through there, we pretty much get them all in STL file formats. Not always, though. Sometimes we'll get them in different formats, and so we'll have to bring them in, design them ourselves, and then save them to an STL file. We'll have to convert them, if you will. And so we have the software to do that. It's a good question because we get them from different formats, but we just have to have the softwares and the licenses with 3Shapes or iTero to be able to bring those formats in.
Right. What are you finding in terms of your for the 3D printing? What are the proportion of products that you're building with them?
Oh man, it's opened up. Initially we were just doing models because we had the forms lab, and that's really what we were limited to do it. And then there was a question of accuracy because it just wasn't accurate, so we kind of even slowed down there. But now with the printer that we currently have, we have right here. We print all kinds of stuff. You can see on this picture, if you can see all these resin bottles, and we have the shaker here, and we have resin bottles over here. We do casting. They opened up new casting. We were seeing casting out, and we didn't do any casting in-house. Now we're doing, casting. And the reason we're doing casting, we still send some stuff out, but the reason we do it in-house is for the turnaround speed. We can print those casts and on the 3D printing, cast them, rather than having to wait 3 or 4 days or whatever the turnaround might be, we can do it same day right here. Ortho, we do ortho guides for orthodontists. We can do, bite splints. We can do, a number of things, quick turnaround that we haven't really done much with it in the past. Obviously, the perfect smile, we've done that in our removal department, but not so quickly with the resin type material that we have now. So that opened up another market for us as well.
Okay. I probably have time just for a couple quick more questions. We try to usually complete these at 15 to the hour because we realize everybody's so busy. But, John, this is pretty fascinating. We have one question. How hard is it to use these printers, and can an old-school lab guy do this?
Oh, you know what? I'm going to recommend – that's a great question. Let me just recommend a couple of things. Here, if you can get this URL here, this Dental. Do you see that screen? You see that screen there, Dental Lab? I want to make sure you see it. Okay.
Yeah, we can see it.
That's my son's lab, and where we have the printers here. If you go here, Dental Lab, there's a 3D print workflow. He kind of does a video here that shows his workflow and how he incorporates it into his lab. And this is a great video to watch to help you understand that. Now, from an old school perspective, we have this is, I hate to say it, but it's almost like a young man's game, right? We have some guys who've been with us for 30 years, and they are experts, in fixed and removable areas. And they on a removable, Dan in our removable area, he goes out and he does some of the 3D printing stuff or the 3D design. It's really design more than the printing part's the easy part. It's really the design where the expertise comes in. Printing it, just setting over in a nesting software and printing it out is pretty simple. It's really the design work. And, we find, I don't see a lot of, and I'm pushing 60 here, so I can say this, we don't see a lot of guys, in the 60, 65-year-old range saying, hey, I'm excited, I want to get into 3D CAD CAM, after doing it 30 years, traditionally. And while our guys have, particularly Kurt, has incredible expertise when it comes to ceramics and comes to understanding every aspect of design, he can help mentor our technicians and give them tips on how they need to do some of the stuff online, how they have to do designs and things like that from a real-world experience. But really, you said for an older guy, that's relative, right? I think old's like 80. So I think that you can adopt this. It's not really that difficult to adopt, and today's software is fairly straightforward and easy to use if you want to put the time in to sit down and learn it.
You're saying that sort of as people have picked up smartphones in the last decade, people will start picking this up. It just becomes a part of how you do work. Yeah.
Or not, right? I know some people who are just at my age are phenomenal on smartphones, and other ones can barely answer it. So it just depends on your level of expertise and your desire to do it. But I'm going to tell you, Jeff, and this is what we've learned, from visiting with other labs and other lab owners and understanding. It's all going digital. Digital is, that first slide that I showed you earlier where it showed all of the, 3D printing in every industry, we're not immune from that. I think you'll find in the next 20 years, people won't be surprised to start seeing, these 3D type printers as they continue to increase and modify and change. And you'll see them in homes, much like we see inkjet printers or laser printers in homes. Years ago, nobody had a laser and inkjet printer at home. Today, everybody does.
Yeah, makes sense. So maybe we'll end with one more technical question because I think this is totally in your wheelhouse. One question about dealing with Galileo and Serec files, and we might finish with that one. Yeah.
So we do that. We have doctors send us those files. We work with them on those files. But everything's sent in an STL format, right? So whether it's from the Galileo, we use those files natively. We typically get those from our doctors in some type of STL format, right? Or an STL format is a 3D model of that. And so they'll send it to us in STL format, and you can print anything that's in an STL format. So as long as it's in a 3D STL file format, whether it's from Galileo, whether it's from, even in we have the Sharon and the Serec stuff here that, we export from the Serec stuff to an STL file format, which is a 3D file format. We have no problems printing those things.
Okay, that's good to know. So the standardized that STL format that's the key for the printing. Yeah. That's really all that's required.
Exactly. Everybody exports to an STL file format. And sometimes they don't. Sometimes if we have the software, they'll send it to us in a raw, manufacturer format, and then we have to take it and we have to convert it to an STL file format. But for the most part, most systems are designed to export to an STL file format because that's kind of like the common standard in the 3D world.
Got it. Okay. Well, I think we've reached sort of the end of the session. I know that we have other questions already queued up, and I encourage anybody who has questions to follow up directly with John. You can reach him through us, obviously, or you can go directly. And John, do you have a slide with your contact information, or is there?
But of course I don't. But let me give it to you anyhow. I should have had that. I didn't even think about putting it on there. But they can give me a call. I'm going to give you my my cell phone number. It's 405-410-3005. I mean, feel free to call me on my cell phone, or they can send me an email. And my email is john.chambers, CHAMBERS, at UnionTech3D. That's UNIONTECH 3D.com. John.chambers at UnionTech3D.com.
And also, everybody, please remember, send anything to us at support@labstar.com, and we will forward it immediately on to John. John, thank you so much. This has been
thank you.
Super illuminating, if I can use that term. It's for us, especially in the Labstar office, we've been talking about this for a couple days now. We're really excited to have a better understanding of how 3D printing works and also how it really applies to the lab. Thank you, everybody else, for making time. And we will continue this series next month when we're going to talk about the secret to using outsourcing with partner labs and milling centers. But for now, John, thanks so much. And everybody have a great week.
Thank you, Jeff. Have a good day. Bye now.